So today we're going to talk about how to model periodic behavior. So here we're given a data of temperatures according to months in Cape Town, South Africa. So we're going to plot this data, and this data is actually going to model a trigonometric function of this form. We're going to find a sine function. So first we're going to do is we're going to draw a scatter plot for this diagram. Now we can just graph it on a coordinate axis, but let's also graph it on the calculator as well. So let's take out the calculator and plot this data on the calculator. So on the calculator, we're going to go to Stat, and you're going to press Edit, and I already put my data in. So on list 1, you're going to put the months, and 1 represents January, 2 represents February, and so on. And we're going to go all the way to 12, and you're going to put the corresponding temperatures right next to it. Now, every pair has to have a 12, 26, so everything has to have a pair for it to graph properly. So when you press graph, it should look like this. Now let me take a couple of seconds to show you how I set up the window. So now notice I set up the window as -1. So January is 1, but I made it a little bit less so that I can see all the points nicely. And I made the max go on to 13, even though 12 was the max. So 13 will just give me a little more space over here. And I scaled the X as 1s because I want to look at every month. And the Y min, that's basically the lowest temperature and the highest temperature. And I'm not going to put just the lowest and the highest temperature, but I just want to see a little broader range of the Y. So I put it at 0 to 40. And that's how I got the scatter plot. Now that we have the scatter plot, what we're going to do next is we're going to find the equation that will best fit this data. We're going to find this trig function in terms of sine function. So our A value here is going to be our amplitude, B is going to be our frequency, and C is going to be our phase shift, and D is going to be our vertical shift, or the midline. So we're going to find D first. So now D is our midline. So to find our midline, we just take the average of the max and the min. So if you look at the max is 28 and the minimum is 15. So to midline is the average of the two. So if we do 28 plus 15, divide that by 2, we should get 21.5 approximately. So midline, it seems to be somewhere over here, somewhere in the 20s range, right? So it's somewhere over here. Just estimating. It seems to be the midline. Right? So now we're going to find the B value. Now B value is the frequency. So notice our period here. So since our period here is 12 months, we can figure out our B value, which will help us figure out 2 pi over 12. If you reduce that, you're going to get pi over 6. So that's going to be our frequency B value. So this is our B value. So great. So we have our D value and we have our B value. So great. So how are we going to find the A value? A is the amplitude. Now amplitude is the difference from the max and the min. So we can just use the difference of the two. So 28 minus 15 and divide that by 2. And we get about 6.5. So that's our amplitude. Great. So now C is our tricky one. So C is our phase shift. Now to find the phase shift, we want to figure out the closest point of the sine function where the sine function will start. So if we take a look at the parent function of the sine function, so we know that if we look at the parent function of a sine function actually looks like this. So it starts at 0, and this actually shows us 1 period. Now notice the parent function of the sine function actually starts at the midline. So in this case, it starts at 0. So to find the C, which is the phase shift of these models, we want to look at where the sine function starts. So here, this is where about the sine function ends, and then it decreases, and here is where the sine function actually starts. And this actually happens to be at the midline. So we are going to use this point right here as our shift. So this point, you could just think of this point as, well, the sine function usually starts at when x is equal to 0, but this just shifted all the way to 10, 21.5. So that's how you can think of it as the shift. So when you're looking for a sine function, you're going to look at where it touches the midline. Now, if it's a cosine function, you're probably going to use this point because this is going to be the shift. So here it will be a shift of 1 if you're looking for a cosine function, but you're looking at for the sine function, which is going to start at the midline. So you're going to use this point. So you're going to just think of this as, oh, a sine function that shifted 10 units to the right. So our C value is here going to be 10. So let's write the equation down now. So C is going to be 10. It's going to be 10. So our equation is going to be T of T. It's going to be the amplitude is 6.5 sine of our frequency, which is pi over 6. Make sure you put the parentheses appropriately. T, because we're writing in terms of T. And then minus, the shift was to the right, so it's going to be minus 10. And then we're going to go shift it up, so it's going to be plus 21.5. Okay, so I think you guys got that, 21.5, even though it's erasing on my screen. So let's graph this on the calculator. And I did this prior, and I actually put this equation in the calculator, just like that. I want you guys to do the same. And then you're going to graph, and you're going to see if that graph is going to touch all those points in our model. And I'm going to turn on my graph because I left it off for a sec. So I'm going to press graph, and there we go. So this graph perfectly models our graph. Now before, when we mentioned that the cosine function is going to have a shift of 1, so let's verify if that will work and put it in the calculator. So let's check if that will work. Now amplitude is going to be the same, so it's going to be 6.5. We're going to put cosine. The phase, the frequency is going to be the same thing as well, because it's going to be 2 pi over 12. 12 is the period, so we're going to press pi divided by 6. In the calculator, you're going to put it in terms of x. And then here, when you have a cosine function, it's only going to have a phase shift of about 1. And that's also about an estimation. And then plus 221.5 is our vertical shift. Okay, so let's take a look at the graph. The red is going to be our cosine function, so let's take a look at it. Oh, there we go. So that's our cosine function for this. Okay, so there's your sine and cosine.